Here we go with problems 3 and 11. Triangles 3 and 11 here. Again, right triangles. But this time, instead of trying to find a side length, we're trying to find the missing angle inside of it. You're still going to use the same thing that we've learned, that same old expression. Some old hippie caught another hippie tripping on acid. And again, this stands for sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent, opposite divided by adjacent. So we look at this figure, and the biggest thing you got to do is you got to identify who's opposite, who's adjacent, who's hypotenuse. Well, if this is the right angle, you and I know this piece is the hypotenuse. Across from the right angle is always hypotenuse. Now, adjacent and the opposite sides can change depending on where the angle is. You and I are looking for this angle right here. So across from it is going to be the opposite. So this 11 is the opposite value, and right beside it that it's sitting on is going to be our adjacent. So you and I are dealing with adjacent and opposite in this problem. Well, this is sine is opposite over hypotenuse. We don't have that. Cosine, adjacent hypotenuse. Don't have that because we don't have the hypotenuse. We have the adjacent and opposite. It's going to be this guy. The tangent is opposite divided by adjacent. So you and I know that in this problem number 3, the tangent of what you and I want is equal to the opposite value. The opposite value is 11 divided by the adjacent value, 34. So we could sit here on the calculator, making sure your calculator is in degree mode, and we could type in tangent of 20 degrees and see, does that come out to be the same as what 11/34 says? We could sit there, but we don't want to waste our time on that and try to narrow it down. There's a quick and easy way. If I want to get rid of this word tangent right here, I'm going to take the inverse of it. So to get rid of the word tangent, I simply take the inverse tangent of it and it crosses it out. But whatever I do to one side, you got to do to the other. So since I took the inverse tangent here to get rid of the word tangent, I got to take the inverse tangent there. So here's what you and I have. Theta is equal to the inverse tangent of 11/34. So take your calculator, type in second tangent. That'll give you the inverse tangent. You'll see a little -1 on it. Put parentheses, 11 divided by 34. Hit enter, boom! Out comes what that angle must be. I did it earlier, and it came out to be about 17.9 degrees. That angle right there, if that's 34 and that's 11, I guarantee your angle right in there is about 17.9 degrees. Now let's look at number 11. Let's see if we can figure this one out. Here's theta. Well, what are we given? This is the right angle, so we know we have the hypotenuse right here crossing the right angle. Here's theta. There's opposite, which we don't care about. We have a measurement right here, which is our adjacent. So we have adjacent hypotenuse. Who's adjacent hypotenuse? Oh, that's cosine. Cosine is adjacent divided by hypotenuse. So you and I know that cosine of that angle, cosine of theta, is equal to adjacent measurement, which is right here of 14, divided by the hypotenuse, which is 35. Now again, I got to get theta by itself. That's a degree measurement. I don't want to sit there and take the cosine of like 60 degrees and see does it come up to be close to it. I want a way of getting the exact answer. So I got to get rid of the word cosine. To get rid of the word cosine, you take the inverse cosine. I take it of this side, boom, goes away. But I got to take it of this side also. So clean that up. Theta is equal to the inverse cosine of whatever 14/35 happens to be. Put it in the calculator. Again, what you're going to do is you're going to hit second cosine button, parentheses, 14 divided by 35, close your parentheses, hit enter, boom. Out will crank approximately 66.4 degrees. This angle would be about 66 4/10 of a degree. We work it based off of this some old hippie called another hippie tripping on acid expression that helps us remember sine, cosine, and tangents. It's a right triangle. We're just trying to find the angle. When you're trying to find the angle, you're going to have to use this inverse cosine or inverse tangent or inverse sine. There you have these two problems for you. Hope it helped.